Ladies and gentlemen, please welcome Professor, University of Oxford, Director, Future of Humanity Institute and of Strategic Artificial Intelligence Research Centre, Nick Bostrom.
Thank you all for coming. I run this research group. We are a bunch of mathematicians, philosophers, computer scientists, economists, and we have the unusual mandate of trying to think carefully about the big picture. One of our major focus of research is artificial intelligence, and we'll get to that. But before, I thought it might be useful as a frame to first reflect briefly on what has happened. This used to be the human condition for almost the entirety of the duration that we have existed as a species. For most of the past 100,000 years, we were hunter-gatherers roaming around on the savanna, living in small tribes. Look at how ripped that guy is there. But after a lot of really hard work and technological advancement, we've come a long way, all the way to what is the modern human condition, which we now take to be the normal way for things to be. But if you stop and reflect, it's really an anomaly from any possible perspective you might look at it. Like it's a perspective on a historical timescale, even more so on an evolutionary or geological timescale. It's an anomaly in space. Almost everything is ultra-high vacuum, and we sit on this thin crust on top of this one little crumb floating around in this vast space. And yet, for most people, when we're thinking about the deep future, any hypothesis that things could dramatically diverge from this is regarded as an extraordinary hypothesis that requires extraordinary evidence. So I think it's more likely that this modern human condition is a transitory phase, and that maybe before too long it will change into some other condition. Maybe we'll progress further to a post-human condition. Another way to make the same point is by just plotting world GDP as a rough metric of humanity's total productive capabilities. I've done that here over the past 10,000 years, and as you can see, you have this very strange shape. It doesn't look like the place we're sitting now is any kind of stable state, like things have settled down. It looks rather that we are in a period of transition. So I like to think about this from a slightly more abstract point of view. You could imagine plotting on the y-axis here some measure of capacity, this level of technological sophistication, and then time on the x-axis. And I tend to think of the human condition being defined as some band of capability there between those two dotted lines, and that over time, and the probability here increases the longer the time frame we are considering, the trajectory is likely to break out of this human condition. And that could be in a downward direction, you could go extinct. That is an attractor state. Like once you're extinct, you tend to stay extinct. It's a stable condition where things could land, right? But there's another one which we could break out in the upwards direction, and I think there too there is some kind of attractor state. Like once a civilization has attained technological maturity, started colonize space and so forth, then from that point onwards, it might just be very likely that process will continue for billions of years until the cosmic expansion makes it impossible to reach further resources. But the likelihood that we will continue to remain within this narrow band seems over time just to diminish, and we're more likely to end up in one of these buckets. And so there are a number of different things that could put us in the lower bucket that could cause extinction. I think all serious existential risks, over the next decades or 100 years, are actually anthropogenic. They will arise from human activities. and it's easy to see this just by reflecting that we've already survived risks from nature for over 100,000 years. We've survived asteroids and supervolcanoes and firestorms. And so if something is going to do us in, it's probably going to be a new thing, and we are the source of most new things. And so there are a number of things that could put us in the down bucket, like including particularly technological advances in biotechnology or nanotech or AI. But among the things that could put us in the upwards bucket, I think that there really is a kind of general portal through which one is likely to transition if one is going to enter this other attractor state. And I think that involves the development of superintelligence. And in principle, there are different paths to superintelligence. You could consider biological cognitive enhancements or some sort of hybrid systems. Ultimately, I think machine intelligence is really the substrate of information processing that will push closest to the physical limits. Ultimately, the kind of information processing that is possible in a machine substrate just will far outstrip what's possible in a biological substrate like a brain. So I want to focus for the remainder of this talk on artificial intelligence. And I guess when most people think about artificial intelligence, they might think of images like these. These are milestones in the history of AI. We have the defeat of Garry Kasparov by the IBM computer Deep Blue. Made a big splash at the time. We kind of forget what a big deal this was. Like now we don't think of chess as such a hard challenge for computers. But once upon a time it was fairly widely seen as sort of the epitome of human intellection. You had to plan, you had to think logically, you had to develop strategies. It like really taxed the human brain. So once machines beat humans in that, we sort of thought, well, maybe chess, isn't really the best test. More recently, there have been advances in legged locomotion, robots, self-driving cars. A few years ago, there was the Jeopardy quiz show where, again, IBM with this system, Watson, managed to defeat the all-time human champions in that. And even more recently, over the last 2 years or so, there has been a burgeoning of interest, particularly with regard to a set of techniques known as deep learning. And some of you might have seen, I guess this was about a year ago, the release by DeepMind, it's now owned by Google, of this AI that could learn to play Atari games, the old classical Atari games that I'm sure a lot of you played when you grew up. So this might not seem such a big deal. What's the use of building an AI that can play an Atari game? And indeed, if all you wanted to do was play one Atari game, then it's not so difficult to build a game AI that can play that one Atari game. The interesting thing with this system was that it could learn to play Atari games just from the raw pixel feed. And it could learn to play any of a very wide range of Atari games, many of them at a superhuman level. So AI now is different from what AI used to be in the 60s and 70s. Back then, it was about building expert systems. You'd have humans that would handcraft knowledge tokens and carefully put knowledge in, and then the AI itself, all it could do is it could make some simple logical derivations. But basically, you got out only what you put in. And now the focus is on learning, on machine learning. And I think that ultimately has the potential to go much further. So behind these occasional blips on the radar of public awareness, there is a set of underlying techniques that make these performances possible. On the one hand, of course, algorithmic advances. Also, we shouldn't forget the progress in hardware capability that has taken place. And if you look at some particular domain, say chess computing, so it has continued to advance since Deep Blue. And roughly half of the improvement that has occurred is due to computers getting faster, and roughly half because algorithms get better. And as a rule of thumb, that seems to hold across a range of different domains. Roughly half hardware, roughly half algorithms. The exact proportion might vary, but both of those have been major drivers. One category where it's possible to compare performance of computers to humans is in various kinds of games, where there's an objective criterion for what counts as successful performance, and computers have, over time, achieved a high-level performance on many of these. The most recent one now is the game Go, which is an enormous game in Asia. It's like bigger in Asia than chess is in the West. And it has, so far, proved elusive. Go is a very complicated game where there are, at any given time, a lot of different options where you can put the next stone. And to decide where to put the next stone, you need really intuitions and pattern recognition skills. And it's not something you can just sort of logically think through. We had a big breakthrough in that just earlier this year. Again, DeepMind created this program AlphaGo that, again, using machine learning, deep learning, combined with reinforcement learning, managed to best the European Go champion. And there is a match coming up 6 days from now in Asia, where AlphaGo, or like a new version of AlphaGo, will go up against the human champion. And in Asia, they're quite far above sort of the European champions. So this is a significant level up. It'll be exciting to see. That will be broadcast live, and so you can follow that if you're into Go. Concomitantly with this, there has been a surge of interest in the academic literature, a lot of publications on deep learning. The technical conferences in this field have sort of started mushrooming, growing by 50% by the year. Also in industry, a number of acquisitions and sort of scramble to scoop up talent in this field. And the major tech companies are all trying to develop some kind of in-house AI effort. So if we look back at AI, since its beginning, it has gone through phases of excitement followed by disillusionment. That in the heydays when they first started out, when they first got computers to play around with, people were very optimistic. They thought maybe you would have the AI problem cracked within a decade or so. Now that failed, and so then there was a period of disillusionment, and the first AI winter, as it is known in the field, where AI became one of these words you didn't really want to have associated with what you do. If you were saying you were doing AI, it sounded a little bit sort of quacky, nobody would want to invest. It's like overhyped things. So that lasted for a while. Then there was a second wave of excitement, which also was followed by the second AI winter. But now we are kind of in the third spring. Like there is now again a sense that the field is moving forward, and a sense of things happening. So already, of course, there are a lot of applications of different things that really are AI, that in many cases were developed in artificial intelligence labs, but that once they really started to work properly, people no longer think of as AI, they just become software, but they do lie in the background of a lot of different applications, and that list is not exhaustive, nor is it closed. It continues to grow. And so when we look at the immense exciting opportunities that are created by renewed advances in machine intelligence, we get very excited. There are some issues as well that people want to think about. So in the nearer term, some of the ones on this list, there's like a debate going on about lethal autonomous weapons. Whether it is a good idea for the world to rush into a new arms race in this direction, or whether there is any possibility of slowing that down in some way through some international agreements or not. Some people are interested in the labor market impacts of automation and are wringing their hands about, is that part of what is causing unemployment now or not? Surveillance and data mining, of course, are big topics. Cybersecurity, applications of that, self-driving cars. So there's a bunch of these kinds of issues, and they are interesting. I think they are serious, legitimate issues. Some people should be thinking and debating these issues. But there is also something above those issues, which is the question of what will happen if and when artificial intelligence actually succeeds. So from the very beginning, the ambition of AI has all along been to create true machine intelligence that can do all the things that we humans can do, the same general purpose cleverness, planning, learning ability that makes us humans smart. So what happens if we actually were to reach that? Just as an aside, we did a survey a couple of years ago now where we asked some of the world's leading AI experts about timescales. We asked them in particular, by which year do you think there is a 50% probability that human-level machine intelligence will have been achieved, which we defined as any machine intelligence that is able to perform virtually any job, at least as well as a normal human adult. As you can see here, the median answer to that was 2050 or 2040, depending on precisely which group of experts we asked. But with a big spread on both sides of that, like it could happen a lot sooner, it could take a lot longer. These are just really subjective opinions. There's no rigorous way to really be very precise about these timelines. But I think the one conclusion one can draw from this is that the view that we might have machine intelligence within the lifetime of some people alive today, it's not a ridiculous view that no serious person holds. Instead, it is actually the mainstream opinion among the leaders in the field. So it should be taken seriously, even if we shouldn't assign like all our probability mass on it. I also think it's important to recognize that if we're going to ask this question, when might we have human-level machine intelligence, we should also recognize that there's a further question beyond that. If and when we did reach that level, I mean, presumably that's not going to be the end of it. Like we're going to say, oh yeah, now we have human-level machine intelligence. Now it's just going to stop there. Now, instead, it's likely to me that if we reach that point, we will very soon thereafter have superintelligence, machines that radically surpass humans, not just in particular domains, but on all the kinds of things that we humans use our brains to do, including scientific research, technological research, social skills, general wisdom. In any case, you want to distinguish these two different questions that you might ask. The question about the first interval there, how far are we now from the point in time when AI reaches some rough human equivalence? One question. Another question, how long from that point until we have something that is radically superintelligent? So these are different questions. You might be pessimistic about the first, think it will take a long time, and yet agree with me that if that point were reached, then the further step to superintelligence might follow, perhaps fairly rapidly. So one way to make this a little plausible is by reflecting on this concept that we have of intelligence, of being smart. So I think our intuitive concept looks a little bit like this. We think intelligence, stupidity. So we have on the one extreme the village idiot. And then at the other extreme we have Albert Einstein or Ed Witten or whoever your sort of scientific guru is. These span the extremes of cognitive performance. And this is because our concept of intelligence is calibrated on our experience with human beings. So we use this concept to think about what humans are capable of, so it makes sense to calibrate it on the variation that we find. But from the point of view of how difficult it is to create a machine that achieves a certain level of performance, I think the picture looks more like this, where we have the AI train starting out at sort of the 0 level back in 1956, or whatever year you want to pick as the start date from artificial intelligence, can do nothing at that point, then gradually over time increases in capability. And maybe after many decades of really hard work, reaches something that is roughly equivalent to the intelligence of a mouse. Maybe it can navigate cluttered environments as well as a mouse can, and make the same discriminations between objects and such as a mouse. And then maybe after a lot of further really difficult work, maybe going on for decades, eventually reaching the level of a chimp, and then after yet more really hard work by a lot of really clever people, the level of a village idiot. But at that point, I don't think the AI train will stop or slow down. I think it'll just swoosh right past Humanville station. The difference between the village idiot and Ed Witten looms large for us, but the basic neurological machinery underpinning the performance of the village idiot and Einstein or Ed Witten is basically the same. I mean, it's the same 3-pound cheesy lump of gray matter, the same 100 billion neurons firing, at 200 hertz. Some minor tweaks, maybe Ed Witten had slightly more neurons in some particular cortical area that was useful for doing mathematics, who knows. But there's no particular reason to think that from a fundamental engineering point of view, it needs to be that much harder to achieve the upper end of the human spectrum than the lower end. And there's a lot more said on this topic. Obviously, this doesn't by any way settle the question. I just think maybe this reflection makes it slightly plausible that it could turn out that it's really hard to get up to even something village idiot, but not that much harder to get far beyond the human level. So if we were to reach that point, then I think that the issues we confront are quite different from the issues I had on that other slide, the more near-term issues, because here we would no longer have something that is just another cool technology. This is no longer like a nifty little gadget, another little cool thing. Here we really have the last invention that humans will ever need to make, if you think about it. Once you have super intelligence that can do all the things that humans can much faster and better, including invention, then you might fairly soon thereafter have general technological maturity. You might have a kind of telescoping of the future. So all those things that you think humanity could have achieved in the fullness of time, if we had been able to work on the problem for 40,000 years, maybe we would have space travel or cures for aging or other things like that. Like all of those things might happen soon after the development of superintelligence. So here we have something entirely novel. Not just a tool, but something that is potentially an agent, something that on its own can have goals and can strategize different ways to achieve it. And we then face this problem, what I call the AI control problem, which is how would you, assuming you knew how to make a machine really smart, how could you then ensure that that smart machine would actually do what you intended for it to do? And this is a big technical challenge. One way to sort of see what is distinctive about it is that what we are really seeking here is scalable control. So we would want control methods that are scalable in the sense that they will continue to work even as our AI system gets more and more capable. So when trying to think about this issue and trying to make progress on it, it's useful to try to make some conservative assumptions here. Like, we don't want our ideas for how we will control superintelligence to rely, for example, on there being a specific reward channel that humans will be able to remain in control over forever, so that we would press a button when the AI does what we want and press another button when it doesn't. That's not scalable. Like, it might work for a weak AI, but for a sufficiently strong, sufficiently clever AI, it might be able then to figure out ways to short-circuit that reward channel, to disable to seize control over the button, or to persuade us not to press the punishment button, or just internally to rewire itself. So that's an example of a control method that might work great up to a certain point, but then suddenly fail catastrophically. Another conservative assumption is we want to assume that the system that we will need to control is capable of strategic behavior, just as humans are, but even more so, including deception. It might, for example, fake incompetence. It might be possible for it to give us verbal hyper-stimuli, that is really compelling verbal descriptions or answers or arguments that will have the effect of persuading us whether or not the argument is really sound. It would be conservative to assume that the AI will sooner or later have access to actuators, even if we maybe in reality will put it in a box, unplug the Ethernet cable, surround it with a Faraday cage or whatever. Like, the conservative assumption would be that that will at some point fail, and we still want it to be safe even if that were to fail. And so one obvious approach to a control method that would be scalable is the idea that we try to align the AI's goals with our own. So if the AI want the same outcome that we want, then as the AI becomes smarter and smarter, it will just be more and more competent at achieving what we want. So it's just good that the AI becomes more and more competent in assuming it has its values are aligned with ours. This is promising but difficult. So there's a risk here of value misspecification. That is, we specify some objective function, and if we get that objective function wrong, then the AI will use its increasing powers in pursuing this goal that doesn't exactly match ours. Now, how much does it matter if this match is not exact? What if it kind of roughly wants something that kind of sounds vaguely similar to what we want? Is that good enough? Well, there's an argument that it's not good enough. In particular, it's been observed by some people that if some parameters, some aspects of human values are omitted, then in many cases, those omitted parameters will be set to extreme values by the optimal policy for pursuing those things that were included in the formal specification. So let me give you some example of that. In a sense, this goes back to the myth of King Midas. That you remember the king who had a wish that everything he touches should be turned into gold, and the wish was granted, and he became very rich. And then he touched his daughter, and she turned into gold. And then he touched his food, and it turned into gold. So you get a kind of literal fulfillment of a wish, which turns out to have omitted some essential qualifications, like, oh, not my daughter, she shouldn't be turned into gold, not my food. But it's hard in advance to sort of remember to put in all the possible qualifications that would make a given explicit goal specification really be such that it would be a good thing if it were achieved. Another example, you might think it's a good idea to design the AI so that it wants to make us smile, and then, when it pleases us, it'll get like more of what it values, and that again will fail when you have an AI that can figure out other ways to make humans smile, more efficient ways to produce human smiles than the ones we had in mind when we laid down this goal. You could achieve that through other ways. So in the literature, this is kind of known with the title of paperclip maximizers. This is like the cartoonish example, but it serves as a stand-in for a broad category of failure, where you create an AI to maximize the production of paperclips, maybe in a paperclip factory, and then it turns out that an AI that has this goal of making as many paperclips as possible will have instrumental reasons to do all kinds of things that are not conducive to human welfare. For example, build more and more paperclip factories. That would result in more paperclips. For example, preventing humans from shutting it down, because if we shut it down, there would be fewer paperclips. So it's not so much that it would have some independent survival drive or a resentment to be exploited or anything like that. It's just that for most possible goals you might specify, there will be instrumental reasons to acquire more resources to prevent humans from interfering. And that is sort of a generic failure mode for many ways of going about it. So how could you get a goal specification into an AI that would capture all of human values, or at least a sufficiently rich description that we wouldn't have these perverse instantiations? So there is a field in machine learning that tries to infer goals from observing behaviors, known as inverse reinforcement learning. So one line of attack here is to try to develop the state of the art in inverse reinforcement learning, and in particular, there are certain distinctive aspects of this that will only really arise once you think of generalizing this to a situation with much fewer constraints. So there are like some distinctive ways of researching this topic that you would not be motivated to pursue if all you were interested in were near-term applications, but that come into view once you sort of have this idea of, securing long-term AI for the world. Another way you can try to maybe make some progress on this general control problem is to create toy models of how control can fail. So to begin to build up better intuitions for particular kinds of syndromes. There's some work going on in that. Yet another, I don't have time to really explain this, is to think of a paradigm whereby you would not explicitly try to teach an AI a utility function that incorporates everything we think about, but maybe instead develop techniques for training an AI to just imitate a competent human. in imitation learning, this is what you're trying to do. And then that has various constraints, like it would be less efficient. Often it's harder to achieve a certain task if you have to do it by doing it in the same way as a human would do than if you could just achieve the task any which way you want. So it makes the problem harder for AI engineers if they have to solve it. That also kind of places some bounds on how competent you could be, because if at the end of the day you have a machine that does exactly what an expert human does, well, that's very useful, but it would be even more useful to have a machine that could do much better than a human expert. So then you can think, are there clever ways to bootstrap? If you had this kind of AI box, like a black box that had this capability of imitating a human expert, is there some way to structure those or to define some sort of recursive procedure on those so that you could bootstrap from those to general superintelligence while still using this as a control method? Another line of attack still is thinking in more architectural terms, whether there are particular architectures that you would have more control over what the different modules would do and the kind of information that is passed between them. So what we have, and this is very new, this has really only existed for a year or two, is the beginnings of a technical research agenda. It used to be that, some people in my group and some others have for like a long time been thinking about these issues and trying to clarify them to the point where some vague philosophical conundrum, how could you control a superintelligence? Clarify that enough that you can begin to break out specific research, technical research problems that you could imagine assigning to a PhD student. And we're now sort of reaching the level where there are a number of these like open research problems and that people are starting to work on. And so just to close and to summarize, I've argued that, well, there are these major remaining challenges in the field of machine intelligence that need to be solved if AI is going to become truly smart. But in parallel with that, there is also an equally important list of challenges that we will need to meet if really smart AI is to be beneficial for the world. I've only talked a little bit about the first item on that, the control techniques that will be needed. And even then, I've only scratched the surface. Of course, there are yet further in terms of thinking about the social impact and all of that I haven't even had time to talk about. But to me, some of these bullets there are really like some of the key the most important intellectual challenges of our time. And there is now the beginnings of a kind of research infrastructure to begin to work on these, and really only in the last like 12, 18 months this is happening. So it will be really exciting to see, over the next year or two, like how this field will progress. If it's still a fragile thing, there are fads and fashions and people's interests wax and wane. But if we can plant the seed here so that by the time, be it 20 years or 80 years or however long it will take, for machine intelligence to reach this level where it can really take off and become super intelligent. If we can plant the seed that by that time will have grown up into a tree that has as fruits the right control methods and the right frameworks for dealing with this in a social context, then I think that could be one of the most important things to invest one's time and efforts in. So thank you very much for listening. Hope you've enjoyed. This used to be the human condition for almost the entirety of the duration that we have existed as a species. For most of the past 100,000 years, we were hunter-gatherers roaming around on the savannah, living in small tribes. Look at how ripped that guy is there. But after a lot of really hard work and technological advancement, we've come a long way, all the way to what is the modern human condition, which we now take to be the normal way for things to be. But if you stop and reflect, it's really an anomaly from any possible perspective you might look at it. Like it's a perspective on a historical timescale, even more so on an evolutionary or geological timescale. It's an anomaly in space. Almost everything is ultra-high vacuum, and we sit on this thin crust on top of this one little crumb floating around in this vast space. And yet, for most people, when we're thinking about the deep future, any hypothesis that things could dramatically diverge from this is regarded as an extraordinary hypothesis that requires extraordinary evidence. So I think it's more likely that this modern human condition is a transitory phase, and that maybe before too long it will change into some other condition. Maybe we'll progress further to a post-human condition. Another way to make the same point is by just plotting world GDP as a rough metric of humanity's total productive capabilities. I've done that here over the past 10,000 years, and as you can see, you have this very strange shape. It doesn't look like the place we're sitting now is any kind of stable state, like things have settled down. It looks rather that we are in a period of transition. So I like to think about this from a slightly more abstract point of view. You could imagine it might just be very likely that that process will continue for billions of years until the cosmic expansion makes it impossible to reach further resources. But the likelihood that we will continue to remain within this narrow band seems over time just to diminish, and we're more likely to end up in one of these buckets. And so there are a number of different things that could put us in the lower bucket that could cause extinction. I think all serious existential risks, over the next decades or 100 years, are actually anthropogenic. They will arise from human activities. And it's easy to see this just by reflecting that we've already survived risks from nature for over 100,000 years. We've survived asteroids and supervolcanoes and firestorms. And so if something is going to do us in, it's probably going to be a new thing, and we are the source of most new things. And so there are a number of things that could put us in the down bucket, including particularly technological advances in biotechnology or nanotech. Plotting on the y-axis here some measure of capacity, the level of technological sophistication, and then time on the x-axis. And I tend to think of the human condition being defined as some band of capability there between those two dotted lines. And that over time, and the probability here increases the longer the time frame we are considering, the trajectory is likely to break out of this human condition. And that could be in a downward direction, could go extinct. That is an attractor state. Like once you're extinct, you tend to stay extinct. It's a stable condition where things could land, right? But there's another one which we could break out in the upwards direction, and I think there too there is some kind of attractor state. Like once a civilization has attained technological maturity, started colonize space and so forth, then from that point onwards,
Ladies and gentlemen, please welcome Professor, University of Oxford, Director, Future of Humanity Institute and of Strategic Artificial Intelligence Research Center, Nick Bostrom.
Thank you all for coming. I run this research group. We are a bunch of mathematicians, philosophers, computer scientists, economists, and we have the unusual mandate of trying to think carefully about the big picture. One of our major focus of research is artificial intelligence, and we'll get to that. But before, I thought it might be useful as a frame to first reflect briefly on what has happened.